Okay, so today's video is called Radian Measure, and it can be used to solve the first 4 questions on the sample test. So what we're going to do is convert between radians and degrees, talk a little bit about what an angle is formed, how an angle is formed, and talk a little bit about angular velocity as well, if it's part of an application question. Okay, and so first off, let's talk about angles themselves and the quadrants. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So for this chapter, we're going to start our angles right here on the eastern axis, or the positive x-axis. Alright, so this is positive x. So anytime we discuss an angle, it will be based from here. And so if I were to maybe rotate up 30 degrees and ask you what quadrant that was in, you would be able to answer that a 30-degree angle terminates in quadrant 1. Okay, and that's kind of the idea. So these would be positive angles. 90 degrees would be here, 180 degrees would be there, 270 degrees would be there, and back to 360. Now if I began to rotate in this direction here, this would be known as a negative 30-degree angle, and it would terminate in quadrant 4. Okay, and that's kind of the idea with how you go with angles. They either rotate this way, counterclockwise is positive, and clockwise is negative, or anti-clockwise if you're from Britain. Anyway, that's a little bit of the radian measure. Or not, that's actually not the radian measure yet. That's just angles in general. Okay, so now let's talk about converting. I'll talk more about the theory behind the radian in class. I want to try and avoid bogging down the videos with theory. We'll save the theory for class, and we'll use the videos only for examples. So we'll convert from radians to degree. This is something that you'll need to do. Well, it turns out that there is pi radians is equal to 180 degrees of rotation. And what that means is, in order to rotate, pi radians is a degree. Here, it's a way of measuring an amount of rotation, and pi radians is equal to a half of a rotation, and a half of a rotation is, as we know from the past, equal to 180 degrees. And so you'll see radian conversions in one of 2 ways. Okay, it'll ask you to take maybe 4 pi over 3 radians and convert it into degrees. So we'll do radians to degrees. Now, in order to convert to degrees, what we've got here is we're going to have to multiply by a fraction. Now that would be pi radians and 180. And the way this works out is the radians actually cancel. Oh, look, the pi's will cancel as well. And so in the end, it's just 4 times 180 divided by 3. Okay? And so that's basically the idea. And then so it would be 6 times 4. This would be 240 degrees. You just have to simplify this. All right, so in order to convert from radians to degrees, you multiply by 180 over pi. You might see it another way. Still from radians to degree, they might just give you like a 3.726 radians, and you want to convert this to degrees. You still do it actually the same exact way. 180 over pi radians, and the radians would cancel, and then in the end you would have 3.72 times 180 divided by 3.14, and that's what you would get. Oop, I kind of lost you there. There it was. And so in the end, you basically are just multiplying by pi over radians. I think I might have lost you up here too. So you can look at it right there and right there. And then you get some number over here. I'm not going to do the math, though. You can just do it here. There you go. Now, converting from degrees to radians is the other way around. Let's go to 65 degrees. We want to convert to radians. Well, you actually just multiply by pi over 180 degrees, and the degrees cancel, and you're left with 65 rad over 180. Oops, 180. Oh, and then there's a pi there too. My mistake. Don't forget 65 pi over 180. And now you're going to have to simplify this fraction a little bit. 5 goes into 65. I don't know. 10, 12, 13 pi over, let's see, how many times does this go into 5? Be 20, 30, no, 20, 46. So it'd be 13 pi over 46. And that's radians. That's how you would get that done. 13 pi over 46. So basically the moral of the story is degree to radians, you multiply by pi over 180. And radians to degree, you multiply by 180 over pi. Okay. Now let's talk a little bit about angular velocity. Okay, this is the application question for this section. And they start talking about angular velocity. It turns out angular velocity shows up in physics a lot, which is why I like these questions. And the way to think about angular velocity is for you to discuss how many angles or how many degrees per second is something rotating. And so angular velocity can be talked about in rotations per minute. RPM is rotations per minute. Or it can be talked about in DPS, degrees per second. And then you also can talk about radians per second, which is not abbreviated RPS, because that would be rotations per second. Turns out just radians per second is not abbreviated, and it's just written out. Anyway, that's how many rotations a thing makes in a minute. RPM is a usual normal for vehicles. You look at a vehicle and your RPMs tell you how often your engine is rotating every minute. So an average RPM would be maybe 1,200 rotations per minute, which is a lot, but not super fast. Because remember, you have a whole minute to rotate around just a few times. Anyway, let's talk about that. Let's say I know that some object is rotating at 1,000 RPM, rotations per minute. How many degrees per second is it rotating? Okay, and so you would start out with 1,000 rotations per minute. This is how I'm going to write it out, okay? And hopefully it makes sense to you. Now, if we want to get into degrees, we have to basically create a fraction over here that has both the numerator and the denominator are equivalent. And I want to get rid of rotations, and I want to go into degrees. All right. And then I also want to create another fraction over here, and I actually want to cancel the minutes, these minutes, and get into seconds. All right. Now the thing with these is this is our plan basically. Rotations, I'm going to cancel, and I'm going to actually, my only unit left up here is going to be a degree. I'm going to be able to cancel the minutes here, because remember this is multiplication. Be able to cancel the minutes, and I'll be only left with seconds, and I'll be in degrees per second. Degrees per second. This is how you can convert. This is my method for converting. This works for everything. You can convert anything except for well, not everything, but most everything. For example, this won't work so well for Fahrenheit to Celsius, or Celsius centigrade to Fahrenheit. So now what you have to do is put here, if, for example, one rotation is 360 degrees. So you have to make sure that this fraction is equal to the number 1. This entire fraction. So if the only way to make an entire fraction is equal to 1 is if you have the same amount of stuff on the top and the bottom. So 360 degrees is equal to 1 rotation. That's the same amount of stuff, that stuff and that stuff. And now this, 1 minute and 60 seconds. That amount of time is the same amount of that as that amount of time. And now we actually can cancel our rotations, cancel our minutes, and in the end I'm left with only degrees and seconds. And so I need to do 1000 times 360 divided by, then we have to, then our numbers are just right here. I take my numbers, 1000 and 360, and I write it over here. 1000 times 360 divided by 60. And now this is in degrees per second. Amazing. And so if I want to do this, to be 360 divided by, or times 1000 would be 360 000 divided by 60 degrees per second. Okay, and now one of these zeros will cancel with that, and now I gotta just divide this by 6, which would be 6,000, I believe. Maybe you'll have to check my math on that. And so it's 6,000 degrees per second. Okay, and that's the idea on how to convert. And now the question would also ask you to convert this into radians per second. And in order to convert this to radians per second, remember, you just take 6,000 and convert it into radians using this method over here, degrees to radians. So I would take the 6,000 and multiply it by pi over 180. So then I would say 6,000 degrees multiplied by pi over 180. The degrees cancel. Oops, I forgot my units there. And so this will cancel with that. Let's see. That'd be 100 over 3, or 33. Well, we'll just go with this is going to equal 100 over 3 pi radians, and that would be also per second as well. Okay, check the math on that, make sure. But so if the question asks for radians per second and degrees per second, you can convert into degrees per second, and then just multiply it by pi over 180 for your radians per second. Okay, this is the video on Radian Measure, and like I said, I'll discuss more of the theory behind what a radian is in class, but these are just some examples for you to get yourself ready for.